Hello, and thank you for joining us today for the third episode of The Download, Hpcc Systems Community Tech Talk, for the community, by the community. This is Jessica Lordy, and I will be your moderator for today. As we get started, I'm going to go through a few housekeeping rules. So first off, welcome. We're so glad that you're here to join us. We hope that you'll share what you're hearing today. Our hashtag is Hpcc Systems Tech Talks. Also, please ask questions. At the end of each speaker's section, we'll go through and answer questions, and we'll try and answer as many as we possibly can. Please also look through for polls throughout the presentation. They'll appear at the bottom of your screen. If for some reason you don't see them, just please exit the full screen mode or maybe refresh your screen and you should be able to see them. Also, we welcome your feedback. In fact, we would really like your feedback. At the end of the presentation, please rate us and let us know how we're doing, what you might be interested in hearing in the future, or how we can improve things. And if you'd like to be one of our featured speakers, please reach out and let us know. I'm going to hand everything over to Flavio Villanustre, who's our VP of Technology, who heads up Hpcc Systems.
Thank you very much, Jessica, and hello, everyone. And thank you very much for being here. It is very exciting. We have a number of very good presenters covering topics that I think are quite interesting for everyone in the Hpcc community. But before we get to the presenters and their bios and what they will be talking about, I want to cover a few important community announcements that I think will be relevant for many of you. The first thing that I want to announce is the fact that we are opening again our summer internship program. And for that, we are still receiving and looking for additional proposals from people that would like to participate. We have just extended our deadline to April 22nd. We got some people that wanted to take a little bit more time to get their proposals ready. And certainly we have a very long list of very good projects that are as part of the rolling list of available projects for the community included in our main portal for internship. There is a link in the screen right now, and the projects are all included there. Of course, if you have an idea or a project or some interest outside of the things that we cover there, well, talk to us, reach out to any one of us, and we can certainly see if there is something that we could work on. We make quite a bit of effort trying to align proper mentors for each one of these projects. And if there is something out there that you would like to do that is not listed, please let us know, and we'll try to see if we can find a suitable mentor and perhaps tackle that project too. Now, the other thing that is important to mention now is the fact that we will have our Hpcc Systems Community Day, as we announced before. And this Community Day will include also presentations, like you've been familiar with our other community days in the past years, and also posters. We will have another poster contest, and we would like to have more people involved with this, more people submitting posters, more people actively participating in these poster sessions, and certainly we'd like to see some winners there like last year. So please try to, if you are interested, to let us know quickly, and of course you don't need to submit any posters or any abstracts yet, but please, if you have an interest, get in touch with us so that we can coordinate and try to get the roster of speakers and posters in a time for us to do the announcements and build the agendas for the community day. Some of the important dates are on the screen right now. You can see that the community day will be held here in the Atlanta area on October 3rd, 2017. As a matter of fact, we might take, as we did last year, an afternoon of the day before and then the full day for that community day. We will have a submission deadline on June 30th, but please do not let this get all the way to June 30. Please try to get in touch with us if you have an interest so that we can try to coordinate things before the deadline approaches. this timeline might be quite tight after June. So if we didn't get all of the proposals on time, we might not be able to change things after that. So please get in touch with us early, even if you don't have enough details on the proposal. We have also opened our community day to external sponsors. The Hpcc community has been growing quite a bit outside of RELX and LexisNexis, and we want to give an opportunity to our partners to participate too with us. So we have sponsorship opportunities for companies and organizations that like to have a booth or some of their corporate information on the site, or even give talks, sponsor talks in this community day. So please reach out to us if you have an interest there, or you think your company or organization wants to sponsor some of this community day. And last but not least, any of the details of the Hpcc Summit 2017 are available online. So go to the portal, take a look. If there is something that you'd like to know and it's not there, just contact us. We'll be happy to talk to you and get the information for you. Last but not least, and this is feeling like a long slide today, we have the new machine learning infrastructure revamp. We have been doing quite a bit of work to get our machine learning capabilities up to the latest platform releases, and also to improve capabilities and performance and stability, particular performance and scalability. And we have now new bundles for machine learning that are coming up in 6.4. This is bundles that are built in ECL for machine learning on Hpcc. You can remember as well that we have integration with other machine learning systems, like, for example, TensorFlow. So this is above and beyond that external integration. So please, if you are interested in machine learning capabilities and or in seeing what is out there within the Hpcc framework, please take a look at, be on the look for these release candidates soon, and go to the GitHub repository for machine learning ECL bundles. Take a look, see what is there. There is quite a bit of documentation on what's going on. And of course, any other requests or needs that you may have or questions, you can also use Jira, use our main Hpcc ticketing system to gather more information and or send suggestions or any other thing that you would like to inquire us about. Now, just moving quickly to the speakers today, and I don't want to delay this anymore. We have a very good speakers. We have very good people that have been with Hpcc for many years, and we have very exciting topics, as I mentioned before. So the four people that we have today aligned for great talks are Joey. Joey is part of LexisNexis Resolutions. He is in Australia. He is part of our optimization groups in Australia. He is a PhD, joined the company many years ago, and he has been involved with machine learning and analytics for as long as I remember, and probably much longer than that. He has a great talk about prescriptive analytics. Some of you might know what prescriptive analytics means, but I'm sure there is always a need for a little bit more information on how that works and how is that relevant to organizations and companies and lives. So Joey has a great talk around using prescriptive analytics and Hpcc, and he'll be our first presenter today. Our second presenter is Jill Luber. Jill, who has been in the LexisNexis Resolutions company for as long as I have been, and that is more than a decade. She is the head of our linking team. Our linking team is the one performing all of the internal and external linking for all of our data. And she will be talking about the move from our standard, well, now legacy SQL-based or MySQL-based ECL repository into GitLab. I assume that not that many people outside of LexisNexis are using the legacy repository, just because our open source platform came with direct support for GitHub and other versioning control systems rather than this legacy repository. But in case you wonder how to migrate from one version control system to another and do that in a way that you don't destroy and burn all your boats in the same act, well, Jill has lots of insight there. She's been running a project to do this migration for some time now, and we are in the process of finalizing that. Now, the third presenter is Michael Garner, who is also part of LexNext Solutions. He's in our HPC Systems platform team, and he has developed a number of things that are under the hood from what you use. He developed, for example, our Hpcc platform init system, and some of the scripts that are used to do the integration and with other components, and some of the Java projects that we have. And in this particular talk, he will cover our Java APIs and Java tools. And for many people there that are Java developers or that know Java and or may have an interest to use some of these Java tools, this will be a very good, I think, insight into what we have today and where we can go in the future. And last but not least, and this is in a homage to Indiana Jones, our very loved Bob Foreman, who is one of our core trainers for Hpcc and ECL, will be talking about the Lost ECL tutorial. His talk has an interesting name, In Search of the Lost ECL Tutorial, and he will be talking about a very good tutorial that is not very well known, that goes over a number of capabilities in the ECL language, including, for example, the graph function, that sometimes is hard to grasp for people starting in ECL. So this hopefully should give a good amount of insight into, for example, building an inverted index using ECL for Roxy. So without any more preamble, I want to open the floor to Joey. And Joey, now the audience is all yours.
Hi, Joey. I think we're having a problem connecting with you. Could you check to see if you're on mute?
If we can't get Joey now, we can certainly move to Jill and then put Joey in the second place, and we can try to contact him.
All right. Let's go ahead. We've got his poll up, so let's go ahead and have that answered if you could. So quick poll, would you use a driverless car? So while Jill is queuing up her presentation, let's go ahead and answer the poll.
Almost there.
We had a great view of Joey's presentation, though. All right, Jill, over to you.
Sure. Hi, everyone. I'm Jill Luber. I'm a senior architect at LexisNexis. I've been with Lexis for more than 14 years now, and during that time, I have been exclusively working on the Hpcc. So I have a poll as well, if you want to present that one.
All right. So the poll is, how are you currently managing your ECL code?
Perfect. Thank you. And as Flavia said, Lexis is, we were one of the original user of Hpcc, and we actually had a legacy version which had a MySQL support for our ECL management. And it's time to move on into more modern technologies, especially the ones that I know the open source solution does support. So I was just wondering how many others out there are actually using a Git versus a Subversion, because you may want to consider moving to Git as well. All right, so let's talk about this migration. This is, again, talking about our ECL code that was previously for LexisNexis. It was contained in a MySQL database. And when we talk about our ECL code, we have code that supports hundreds and hundreds of data builds on Thor and hundreds of products that are in production for Roxy, and with thousands of data sources, right? So this is really a ton of code that's been developed for more than a decade. And how do you basically change the wheels on the car while the car is still rolling, right? That's the challenge here. So what we're going to move to is we're moving to an enterprise version of GitLab. If you aren't familiar, GitLab is a service provider of the Git technology. There are others like GitHub. We have chosen a GitLab implementation, which we are housing within LexisNexis, and that's where our ECL will reside. And I've put the link there in case anyone else wants to know a little bit more about GitLab. So why are we migrating? Well, one of the biggest advantages of Git is the ability to branch the code. This is not something that we had with our MySQL solution. Creating branches not only for a production version and releases, but also to have your own development space. This is something that's new to us, and I think there's huge benefits, and I'm gonna demonstrate one of those in a moment. Again, release management, having a static version of code that is being used in your production system that you can then make changes to, hot fixes if that's necessary, or really get an understanding. If you need to go into that archaeology of what's in production for support reasons, you've got that available. And also a distributed code base. Having the ability to have, again, lock down your environment for your developers so that they make sure that they're the only changes going into the code are their own changes. They're not flying blind in that way. And just having the ability to work offline even, right? With a distributed code base, when you have it all local, you can even work on a plane, right? And you don't have to be connected to have the ability to continue development. Right. So I'm looking at the poll, and it does seem that most of you, more than half, are on Git, and that's great. There's still some on other code bases, and so I think this would be relevant to you too. Even if you are on Git, I've got some tips in there about code structuring that may be helpful as well. So how do we move forward? Again, how do you change the tires on that car while it's still rolling? And the first thing we want to look at is how the code is structured. With our MySQL solution, we had separate repositories. We had a dev instance, a QA instance, production Thor, and production Roxy. And we actually had this kind of migration path, right? Code would actually move along that path as it went to production. With Git, we're going with a much more simplified structure. We have a Thor master. This is a master branch in Git that contains all of the production-ready code that will be used to do our Thor builds. We're going to have, similarly, a Roxy master, which is going to have all of our production-ready code for Roxy deployments. Excuse me. From that Roxy master, that's where we're going to create our multiple Roxy release branches. So imagine it's time for a release. Right now, ours are biweekly. And what's going to happen is you're going to take that Roxy master, you're going to branch it with, and then really lock it down with the date of the release, and that is the branch that's going to be used to compile the code that's going to then go to production. So as far as code structure goes, lesson learned here, and again, it's harder when you're migrating, but if you're starting from scratch, I really think that if you could maintain your file references and layouts in a completely separate project and have it shared between your different environments or even your different products, that is really going to simplify your life. We have the difficulty where you have the layout that's really tied to the data that's in the dolly. And so you can imagine if you're sharing a code base but have different dollies, you have some layout coordination issues there. If you could keep that project separate if I could go back and do it all over again, that's how I would start. I really think that's going to help keep your dependencies and keep the separation clean. So how are we managing this migration? We had to decide, what goes first. One of the decisions we made was to actually go with our Roxy deployments first. A couple of reasons here. There are fewer touch points. What do I mean by that is, for one, there's fewer users. I talked about we only push to production on a biweekly cycle, so really you're not touching that code nearly as often as your developers are. Fewer users because you've only got there's permissions such that there are only certain people who can access that production data and then deploy it. We've also found that we've got the biggest operational improvement opportunities when it comes to Roxy. Again, this is our customer-facing code. And I'm going to walk you through an example now of this. Actually, so what's happened is we migrated our Roxy code over to Git and started creating these Roxy release branches and using those for our production deployments. In the very first week that we moved over to Git, this exact example that I'm going to walk you through is what happened. So this is how our code looked before. We have this MySQL database, and we would deploy to a certification Roxy, and forgive my abbreviations here. And then from the certification Roxy, we would move those compiled queries straight into our production system. Okay. So let's say we're now in production, and our developers continue to push new functionality and changes that they're queuing up for a production release into the MySQL repository. Well, now we've found a bug in production, right? We've got a bug that we really need to fix immediately. In this current schema, the way that you would go about fixing that bug, well, the first thing you have to do is roll all the code back. What was in production, now you have to basically reset what's in your MySQL database. You have to make a hotfix directly into that MySQL database, move it to certification, move that to production, and now try to push back in those changes that you rolled out for future production releases. So at the end of all that, you kind of look like this, right? So this is how I felt after any time we had this kind of emergency hotfix before we were on our Git solution. So now let's see what this looks like. Same situation with Git branches. So we have our Roxy master branch, and when it's time to do a production release, we create the Roxy release branch. That is the branch that is then going to be used for compiling to our certification Roxy, and then eventually move to our production Roxy. Once we're in production, we continue to update that Roxy master. Again, new features, new functionality. They're all ready to go into a subsequent release. And there's that nasty bug again, right into production. Now, in the case of Git, there is no rollback, roll forward, right? There's not a lot of code coordination here. Really what we're going to do is go directly to that Git branch that represents the code that is in production, make our hotfix there, and move that on to production. Right? Roxy master continues on its path of being updated with code that's ready for the next release, and we've made our hotfix without having to do any of this big coordination effort. So literally the first week we moved to Git, we had this exact situation, and it was like this hallelujah moment when it was so easy just to make our hotfix and move on. So where do you begin? So I talked about generally we're going to go with Roxy first, but but how do you do that? So what we do is actually, first thing you need to do is move all of your ECL code into Git, right? And how do you even do that? Well, we actually just wrote a quick little C++ tool that really downloaded all of the code out of the MySQL database and uploaded it into a master branch into Git. And we even made that automated so that we can continue to update Git while our developers were continuing to push into our MySQL development space. The next thing you really need to do is when you need to start changing your processes, right? So much about the migration is not technical, and it's about changing processes and people, which is why it's difficult, actually. So what you need to do now is change your migration process. So let's keep our developers. They're still in MySQL world. They don't know any different. But the migrators, the folks who are responsible for promoting code into a production state, they continue their normal path, but they have to add an extra step, which is not only should you migrate to the way you always were before, you have to push into Git as well. After a few weeks, and we've got that process down pat, at this point we can verify that the code that is in the MySQL database and the code in the Git branch are equal at any point in time. Right? That's really the point there. Then we can start to create those release branches I talked about for our Roxy releases, and even deploy. So again, your developers have no idea that you've done anything as far as changing your code base. They're moving along as they always were. And again, for us developers, you're talking about numbers in the thousands. Where deploying to Roxy, we're really talking about numbers in the dozens of users that are really 1 dozen that have to change their processes at this point. Just to note here, when you're compiling with a Git branch, you'd need the ECLCC server. Currently, we're suggesting versions 5.6.8 or 6.2.8, and then obviously later 6.2.8 is the most recent that's available. And obviously, you want to stay up to date with the latest versions. But if you're not on these versions and you're using the ECLCC server for compiling, you may find some errors that we've encountered along the way during this migration that have been fixed in these versions of the platform. So now we've got Roxy in production, using Git, everything's great. The next thing you want to do, or kind of stepping backwards into the process, the next step for us was to automate the Thor production builds. So we have daily, even sometimes on demand, within 4 hours, these builds that run, that accept new data onto our Thor, build the data, run our ETL processes, and publish the data. We changed those automated Thor processes that were usually scripts on a Linux box, and they need to now stop submitting the code via the MySQL repository and actually pull the Git code. So you have to make sure that you have a process that can pull the Git code onto the server and then submit through that ECLCC server. So moving those production Thor builds was the next step. And then the last step, and I said this is the hard part because this is not about machines, this is about moving people, and people are the hardest thing to move. What do we need to do to move those developers? I think in Git, and the Git supports so much of this, our GitLab does, I know GitHub does as well, setting up permissions in your groups. So we have a large group for our developers that are going to be touching ECL code. And then, there's so many controls that we have, even per branch, where you could say which users can and can't update, can accept pull requests into those branches, and that's been a big help here. We also need to establish those migration roles and best practices. Like I said, don't forget your code reviews, and I think, again, the Git tools really help this workflow where you have a pull request, but it won't be accepted until there is a code review that you can see there that someone else has signed off on it. Also the last part on migrating developers is training. You've got to make sure that your developers understand the Git model. If you're new to Git, it is a bit of a learning curve. It is going to be a drag. I went ahead and called out there's a productivity drag initially with the learning curve of Git and branching and pull requests, right? So that whole process. But there's so many materials out there. I feel like that training is really easy to get to get your developers moved over. Things to consider before migrating. Just again, some tips that we've discovered. I talked about most of these during the presentation here, but just to call them back out. Code structure, again, how many projects do you need? Can you separate your repositories by products, by processes? If you can separate them and break them down, the more the better. And again, I said a suggestion I had was, again, the layouts, getting those into a separate project if possible. Your history is going to build up, and as you have to download that code base, obviously the more structure you have there, the better. Again, those permissions, it's just a great feature that's really built right into GitHub and GitLab. Again, once you have that installed, the permissions really are what help drive the whole process. Again, the people are the hard part to change here. Issue tracking. You really want to integrate as much as you can. I know GitHub has a nice issue tracking tool. GitLab does as well. We were actually already using Jira, and we now have written just some Python, actually, to integrate the APIs between the Jira and the GitLab, such that we have this one-stop shop where you can see here's the issue, here are the files that were changed, here's the code review, here was another commit on it. You could just follow the whole thing, and I really think that's important, and that's going to actually back to the drag on productivity. Just to learn Git, once you get all this stuff integrated, you're actually going to see a quick uptick on productivity as a result. So as much as you can integrate, I think that's important too. And then the last, again, prepare your team, making sure that, again, that learning curve, as much as you can help that. There's videos out there. There are books and books on how to use Git. I used one called Pro Git, which was really, again, the concept of Git really doesn't matter what provider you're using as far as GitHub, GitLab, etc. It's really the concept of the branching. And with Git, there's definitely 100 ways to skin a cat here, but I think that's the most important part, is getting those best practices and code structure, getting all that decided up front, and then before you roll that out to the team, make sure they understand what the benefits are and the differences with Git. So that's all I had for our migration. It was short and sweet, but just wanted to give you guys some tips and ideas of, again, how to change those tires while you're still moving. It is possible.
All right, fantastic. Jill, thank you very much. We've got several questions in from the audience, so I'll give you a chance to look at those. And while you do, I'm going to call out to Joey to see if he's been able to resolve his technical issues.
Hello, I'm here. Can you hear me?
Oh, fantastic. All right, we're going to go back to you in just a second. I'm going to go ahead and start asking Jill some questions. All right, so our first question. Should I rather use tags or branches to manage attribute versions and releases? And if so, why?
Sure. We actually had this debate internally too. Tags, to me, are more like a frozen point in time. So you could imagine that does fit well with a release, as in that's static. Here's a picture of the code as it was at this. It's more like a timestamp. The reason that we chose branches instead of tags for our Roxy releases is because back to that little illustration I showed you where you've got hotfixes, I actually do want to be able to alter my branch and have that commit history in there so I can see if there was a hotfix or if we had to roll something back or change something on a version of the code that was in a production at a certain point in time. I have that with a branch. It's a little trickier with the tag. It really depends on how flexible you want to be with your releases. Another option with tags is if you have that hotfix I was talking about, you take your existing tag that's in production, you can branch from that and create a brand new tag, right? So there are definitely options around using tags versus branches, but we did choose the branch. I think it was, again, just preference. And it was, again, because we knew we want to have that ability to alter what's in production and keep track of that.
All right, great. Thank you. It looks like we have another question here. How does Git prevent your code from being overridden if two people check in one after the other?
That's a great question, too. So Git, and specifically in GitLab that we're working with, have great tools for diffing. And there's a couple of different ways that it works. One's a merge conflict, and what's happened there is it's really dependent upon what they call the head of the branch. So it knows what was the status of the code, what branch did you start with before you started making changes. And if two people branched from the same head of the same ancestry of code, and then they're starting to check in. We say check in really for GET. It's a pull request that's been accepted, and then the subsequent pull request, the GET solution actually tells you, hey, look, there's been a merge conflict because you're trying to do a pull request on the head of a branch that's different than what I've got as my current version, and it will highlight per file the lines of code where there's a merge conflict. So the tools are really, really good with helping you resolve those merge conflicts. In some cases, the merge conflict is like you added lines 1, 2, 3, someone added 4, 5, and 6. I can just slap them together. Is that okay? And a lot of times it is okay, and you can say yes, move forward. Like I said, so the diffing tools that actually exist in GET are so much better than what we were working with MySQL. I mean, that exact problem of two people trying to change something around the same time actually is one of the other big reasons why we're moving off of MySQL. And I believe even some Subversion, I know some folks who use that who have the same similar issue. So I think that GET, it's just, again, go if you can, Google it, just look into GET a little bit and some of the tools that are out there. GitHub's the web-based that's even free in some instances. Way to manage your code, and it is superior. Again, I can't say enough. It's a little bit of a learning curve, but certainly a better way to manage your ECL code, in my opinion.
All right, thank you, Jill. So now that we've got Joey back with us, I'm going to turn it back over to Joey so we can go through his presentation.
Thank you. Apologies for the technical glitch. So let's look at the result of the poll. I think I started with that earlier. The result is pretty much what I expected. That's similar to polls done elsewhere, which is about 40% yes, about 50% no, and about 10% not sure. So hopefully I'll shed a bit more light about why I started with that poll throughout the presentation. So the ultimate goal of data analytics is to improve outcomes using insights from data. The development of data analytics capabilities in an organization usually takes several phases. The first phase, starting from left here, is curate, so where systems develop to collect, manage, clean, and share the data. The second phase is collate, where systems are in place to enrich, link, summarize, and produce reports using the curated data. So this is the phase most organizations usually achieve. The next phase after that, which is describe, aims to translate the data into insights using analytics to describe what happened and why. The predict phase tries to extrapolate and predict what will likely to happen in the future and why. And most organizations who have data analytics and BI capabilities usually are at this phase. But in order to reach the goal of improving outcomes, we need to take a step further and turn those insights into decisions. This is the goal of the prescribe phase, or the prescriptive analytics. It tries to answer the question, what should I do and why? So note that in the literature, however, that there is another separate phase called the diagnose phase or diagnostic phase. But in my opinion, diagnosis should actually happen throughout, which is why I added the phrase "and why" as part of every phase: describe, predict, and prescribe. So today I'll be talking about the software challenges around building prescriptive tools. So note that I'm referring to prescriptive tools rather than prescriptive analytics, because I want to focus on the software solutions rather than the techniques and methods. Predictive tools are software solutions that turn insights into decisions. So let's have a look at this simple picture here. This is going back to the poll that we had at the start of this talk. But there's a note, however, that for driverless cars, they usually take the prescriptive tools one step further, and I'll talk about it in a moment. But for now, let us limit our scope to just prescribing the actions and decisions in this particular scenario. So consider the scenario here. Suppose you're driving in Australia, which is why in the picture you're on the left side of the road, and there is a kangaroo that hopped into the middle of the road and just paused there. There's a bus driving on the opposite side of the road, and by the way, kangaroo is a marsupial. It's a big animal, about 1 meter high, usually 1 meter tall. So at this point, we do not yet know what's on the rear view mirror, so I omitted that from the picture. I also would like to apologize for the quality of my artwork. You can see why my grade school teacher tried to discourage me from becoming a painter, so I became a software engineer instead. But anyway, as you may have guessed correctly, I also failed miserably in trying to do the kangaroo, so I just used a clip art picture instead. So let's suppose you were to design a system that would prescribe the best course of action. Think about what the components, what sort of components would be required. So for now, let's just assume that the computer vision problem is perfectly solved. That means that we have a system that could recognize all the elements in the scene correctly. So let's focus on the problem of, can you have a system that will prescribe what is the best thing to do to describe the best outcome? So let's keep that in mind as we go through the next few slides. So back to prescriptive tools. The value proposition in building data analytics and business intelligence capabilities is to improve outcomes, usually business outcomes. Prescriptive tools are key to realizing this value proposition. So in this illustration, the y-axis on the left-hand edge of the diagram shows the different phases: describe, predict, and prescribe. The y-axis indicates the timeline, so the past, the present, and the future outlook for the business. So starting from the bottom left corner, we see reporting, visualization, and dashboards. Those are usually different ways of describing what has happened or what is happening. They provide valuable information and operational insights. Scores and forecasts are interesting. What they do is they relate descriptive attributes to future states or outcomes in a business-as-usual scenario. They forecast what will likely to happen under the default no, do nothing scenario, so don't do anything kind of scenario. Scores are classification labels, so they relate the descriptive attributes to future states or outcomes. Although they might imply which variables could control the outcomes, they do not indicate how to adjust the variables in a way that would influence the forecast towards a desirable outcome. Alerts are also interesting because they take scores and forecasts a step further by having thresholds when something must be done. So it's actually saying do something other than do nothing. And the required action might be implied, but without prescribing explicitly what the actions should be. It is worth noting that as we progress along the timeline from past to future outlooks, the level of uncertainty also increases. So the nature of the decisions and actions that we need to take also change from informational, operational, and tactical to more strategic actions and decisions that can have long-term impacts. So as the uncertainty increases in the forward projections, the options and constraints change over time, and as more assumptions have to be made when making those decisions. So what do we do? In high uncertain situations, we need to consider several what-if options. So the simulation tools allow us to consider various combinations of actions and assumptions and their likely impacts and outcomes. So as humans, we do this all the time. So we do these kinds of simulations in our heads all the time. When making decisions, we consider various what-if scenarios, but sometimes the number of options, the number of combinations, can be a large combinatorial problem, and this is when we need simulation tools to go through the different options. And that's where the optimization tools come in. So what they actually do is search through those combinations. It's really just a search tool. And what they do is they try to find the ones that satisfy the business constraints and lead towards the business outcomes. So one important thing to remember in optimization is it relates the insights, the analytics, to business objectives and constraints. So note that prescriptive tools aim to support decision making, and they do not go as far as automation. So although I showed the picture of a driverless car earlier, that actually is taking it a little bit further, because in those systems, they execute the decisions autonomously. So in our case, we just want to have something that will prescribe an action rather than actually execute them. And that can have an impact later in the design of the software. So to illustrate what I mean by combinatorial problem with options and assumptions, so consider the application in price design. So this is in designing, determining prices for insurance premiums. So this is usually what we used to do. Suppose we want to adjust prices to make our premiums competitive, but in a way that would still keep our business viable and profitable. So the price designer has several levers that they can adjust. For example, there are several attributes or variables that describe the market segments, such as driving history, geographic location, and so on. And also for each of these attributes, there can be several levels. And for each level, there could be several coverages. So imagine trying to figure out the right combination of prices that would deliver the best value for both our customers and the business. And even if suppose we have a button that actually says match competitor relativity that would make those adjustments for us, how do we take into account how our customers and our competitors would respond to those price changes over time? So as soon as we change the price, our competitors might also change theirs, and so on and so forth. So there's a bit of feedback loop. So these are the challenges the simulation optimization that prescriptive tools try to address. At this point, I'd like to do another quick poll. If you could, please tell us, do you work with prescriptive tools in your current role? Please respond using the poll at the bottom of the screen. With that in mind, let's take a quick look at the software engineering challenges involved in building prescriptive tools. For example, here's a diagram of the elements required in price design that I mentioned earlier. I originally wanted to use this diagram as an example, but in the interest of time, I opted to use a simpler example instead. And that's why we're back to our friend here. So this picture helps us illustrate the particular characteristics and elements involved in engineering predictive tools. A very common component is urgency. Time is usually the biggest constraint. Sorry, not the best, the biggest constraint. The desired outcomes often require fast decisions involving multiple competing objectives and constraints. What do I mean by that? In this example, we want the best outcomes for ourselves, the kangaroo, and the bus, the passengers and the driver, of course. As for the constraints, there's the current speed, the curb, the road, the tree, and so on. So aside from the time sensitivity, the possible solutions are also not unique. So one of the consequences of prescriptive tools is requiring some human-computer interaction in prescriptive tools is that they need to be more transparent. So they tend to be black boxes, but because they need to get the user to actually buy into those prescriptions, they need to be more transparent. The user interface has to allow the users to specify various objectives and constraints, and also to interrogate the results of the intermediate calculations. And then onto the more numerical stuff. The number of combinations of possible actions can be very large, and the outcomes, the predicted outcomes, can be very sensitive to small perturbations. So I mentioned earlier the issue of the feedback loop. So for example, in this case, what are our possible actions? Well, you can brake, you can toot, you can swerve, or well, you can stream. You can also maybe take a photo, although I'm not sure if that will actually help, or accelerate. So any of these combinations of actions could have an impact, but there's also almost like a feedback loop. So as soon as you do one thing, the other agents in the seed will also do another thing, and then you have to adjust. So this is where the simulation will try to predict the outcomes over a longer term. For this to work, we need to engineer a system that can use fast algorithms, but at the same time also are numerically stable, so not so sensitive to those large and small numbers. It needs to be fast. It needs to be able to do parallel calculations. It needs to be able to search through various results. You can have global and local optima. And most of all, for the user, they need to be able to visualize that information rather than just give them a number that they might not necessarily believe. The predictive impacts of various activities involve causal and response models with complex dependencies that are sensitive to assumptions and the initial parameters. And what do I mean by that? You need to be able to predict how the kangaroo would respond and how the bus driver will respond. For example, when you toot or when you brake, the conditions of the road would be one of those considerations as well. From the software engineering perspective, that creates a challenge because most of those models reuse behavioral rather than descriptive attributes. So rather than things like, for example, in price design, where you might be related to age or territory, those are descriptive attributes. These ones are behavioral. So these are things like what they're doing, where they are, and who did they influence, and so on. And of course, because it's behavioral data, for example, on roads, that would be like telematics data. They are large data sets with lots of noise. So you need a system that would do proper hygiene and enrichment, and probably do some batch processing online so you can do fast queries when we need them online on the road. So in order to address these software engineering challenges, you'd need a high-performance system that can do both batch processing as well as respond to fast queries for models, and Hpcc does that. Now, unfortunately, in the interest of time, I won't be able to get into the details. Hopefully, I'll be able to do that at the Hpcc summit. So let's see if we get an opportunity. But so just to say, these platforms have the capacity to deal with the challenges that I've just mentioned. So to summarize, prescriptive tools are necessary to deliver the business value proposition of data analytics and business intelligence solutions, which is to actually prescribe actions that will lead to better outcomes. It does so by simulating various scenarios and selecting options that can achieve outcomes that align with the business objectives. And there are several elements and characteristics that present software engineering challenges, such as multiple competing objectives, large number of options, and causal and response models that are quite complicated and exhibit dynamical behavior. And a high-performance cluster computing platform can help meet those engineering challenges. And by the way, no animal was harmed in the making of this presentation. Thank you for your time.
All right, Joey, thank you so much. So while Joey takes a moment to look at the questions that have come in, I'm going to step back and look at the results of this poll. So the question was, do you work with prescriptive tools in your current role? And 76% of you said that you don't today. 14 said that you do. And 9% said that you're not sure, which is perfectly fine. So for the 76% that said no, if there are other topics or if you want more detail on prescriptive tools, put that in the Rate This tab. Give us your comments, and maybe that's additional content that we can develop for the future. All right. Joey, you ready for some questions?
Yep.
All right. Did you need to create visualizations from Hpcc too? And if so, what did you use?
You mean for this presentation, or so the visualizations from Hpcc? Oh, I see. So there are actually some tools that are built to help visualizations for Hpcc, and we can provide that information in the blog shortly. So they're open source, and they link directly with Hpcc. Yes.
All right. And are there any open source analytical tools that are available for Hpcc in the form of ECL bundles?
The machine learning bundle, which Flavia mentioned earlier, provides a lot of the tools that would be very useful for this kind of work. Yes.
All right. I'm going to ask one last question. We have a few in, but we're running short on time. So if prescriptive tools can already determine which actions will most likely lead to the best outcome, what's left for the decision makers to do?
Yeah. Prescriptive tools do just that. They prescribe. So executing the decisions and the actions, such as in the case of self-driving cars and high-frequency trading algorithms, they're actually outside its scope. So I often have the checklist of caveats whenever I present the results of prescriptive tools. And top of the list is that prescriptive tools are just that, they're tools. And decision makers cannot devolve to those tools the responsibility for the actual outcomes. So the proposed course of action is only as good as assumptions encoded in the tools, and the tools can only suggest which option is likely to be the best outcome. The tools also cannot come up with those options. The decision makers need to come up with those options and assumptions, and also there is no substitute for the common sense or the decision maker's skill in balancing objectivity and gut feel. Well, not yet anyway. But for us, for the software engineers, that means that we need to design the system in a way that the end users can interact and believe in what the tools prescribe.
All right, Joey, thank you so much. All right, we're going to go ahead and get back to our normal schedule, and I'm going to turn everything over to Michael. It looks like we're pulling up Michael's presentation. We should be ready to go in just a second.
Thank you very much. Just wait 1 second for us to get to my slides. Sorry about that. Okay. We're going way past it now. I'll take it from here.
All right, thank you, Michael. Sorry, we've got technical difficulties today.
Okay, so a quick poll. Have you ever used the Jdbc API or any of these tools and API in your daily work? So let's kick this off. This is just going to be a quick rundown of what the Hpcc, Jdbc, and Jdbc tools are, and how you can go ahead and implement them and use them in your Java projects. Because recently, these projects were hosted internally. So if you wanted to easily implement them in your projects and you were an internal customer, you could. But if you were an external customer and you were building a tool for Hpcc, despite the fact that all these tools were open source, you couldn't easily integrate them into your project. But now that we've moved from using CMake for the builds and over to completely using Maven, you can go ahead and just plug and play with these APIs. So what these APIs are, we have WS clients, we have RDF to Hpcc, client tools, and our Jdbc driver. So real quick, our WS client is a Java API that connects you to our ESP services. It's built off of the generated WSDLs, okay, and that means that you have a consistent API for every single version of the platform. The reason why we ended up doing this is we noticed a lot of end users doing ad hoc SOAP calls in their Java applications and making connections to ESPs that were inconsistent and were error prone. A lot of the downstream developers really didn't have a good grasp of what the proper work unit flow was. So we went ahead and we implemented these things in our own library to help facilitate the use of the ESP services. RDF2 Hpcc is a tool that takes the graph-based RDF data and goes ahead and allows you to ingest that into the Hpcc platform. So the reason why this is useful is that RDF is a data model that's used in quite a lot of different application domains. So you can go ahead, if you're using RDF data, and then move it over to the Hpcc platform if you deem it necessary. And then we have the client tools. And what client tools are, right now we have one client tools currently built, but the framework for creating these client tools, if anyone ever wants to go ahead and contribute to these, it makes it very easy to create a small library to extend functionality of general things that you do throughout the day in Java with the Hpcc platform. So the current client tools that we have up there is called ECL Compile, and that was originally written by Hari Chidaluru, who's on the RAMPS project. And it allows you to just compile ECL through a Java class and then use it how you see fit. Then we have our Jdbc. And for those of you who work a lot with Java, you probably already know what a Jdbc is. It's a Java database connectivity tool. And it's basically a driver that allows you to implement your code as though you were talking to a SQL source. And you're able to just plug our Jdbc driver into the code that you've written towards that Jdbc API. And now, even though you normally wouldn't be able to talk to an Hpcc platform as though it was using the SQL language, you can now go ahead and do that. It makes it really easy if you're writing a single database application and you want to connect with an Hpcc platform. And it allows you to use the Hpcc platform as a data source directly to your code. So one of the big things that we've recently done is, I was talking about earlier at the start of this, how we were going from a internal hosting to an external hosting. So that way, even if you're not an internal customer, you can still have easy access to these already open source tools. Part of the build changes were we went from using CMake to build a lot of our code to exclusively using Maven, which is a Java-centric tool for building and publishing. So now what we do is we publish to the Maven Central Repository. And what this allows you to do is, if you're a downstream developer, all you have to do is take a little bit of the code that's on the right, a small little dependency block, put in our group ID, the artifact that you want, and the version, and it fetches it for you automatically, and you can directly code to our API without any hassle. So a couple places that the Jappy project is currently getting used right now. You have the Circuits ECL Pentaho plugin, Logi Analytics, ECL Builder, Zoom Data. I'm certain a lot of us here have probably heard of Hippie, WSSQL, Flow, DSP. These are all places where this underlying API is getting used. And so these are a group of people who have contributed in the past towards the project, or we've taken input from them in different ways. And so it's a fair amount, but we would always love more. So please, if you're ever interested in contributing to the JAPI project, please just get in touch with us. And the potential future for this project is we want to do more tools from the actual platform and write them into Java so you can use them in your code directly through using the Client Tools library. And we also want to eventually automate the validation of ESP services that get written on the platform, which is fairly low level. And we want to be able to automate the interface through previous versions to make sure that they're all compatible, which has been an issue in the past and something that we're look to fix in the future. So here's some quick resources. If anybody's interested, they'll be on the slides, which you can grab later. And just a real quick poll for the end is anyone here actually familiar with the Maven Central Repository? Hopefully some people are.
All right. So while Michael takes a moment to look at the questions that have come in from the audience, I'm going to step back to the first poll. Have you ever used a Java API or a product which uses these tools or APIs in your daily work? And 38% of you said yes, and 61% no. So hopefully you guys have learned something that would be really helpful in the future. All right. All right. Are you ready for your questions, Michael?
Yeah, let's go ahead.
All right, perfect. So the first question is, how efficient is the Jdbc interface? Do queries get converted into ECL? And do they use existing Roxy indexes and queries?
So they do get converted into a form of ECL. You don't get to use the full features of the language, unfortunately. But as far as Roxy indexes and queries go, I'm not entirely certain on that. I would have to ask the architecture. I am the maintainer of the Jdbc project, not the brains behind it, unfortunately.
Ah, okay. Is there a JNI interface for ECL or Hpcc?
All right, so it's not really. Basically, you can go ahead and no, it's not to my knowledge. Sorry, I don't have a better answer for that. I'm more of a builds and platform and maintaining. The architecture is Rodrigo Pastrana, and he's really the brains behind most of the actual implementation.
All right, perfect. That's perfectly fine. Let me go ahead and ask you one last question. Is there a WS client compatible with multiple versions of the platform?
Yeah, actually. Recently, a lot of people have been using both 5 series and 6 series ESPs, which can sometimes cause a problem. But what we've gone ahead and done is we make sure that, dependent on what ESP we're calling, that we're using the correct API in our actual code. So that way, you as a end user don't have to worry about which ESP you're targeting. We take care of it for you. So you can go ahead and use it for multiple versions of the platform at the same time.
All right, that sounds great. It looks like one question just snuck in. And is there a tutorial for using Java ECL plugin?
There isn't a tutorial so much as there's basic instructions. We can go ahead and point you at documentation for using the project in your Maven project, and I can give you documentations towards the API, but there isn't a tutorial per se.
All right, thank you so much. There are a few other questions, and please note that we can't get to everything today, but I will reach out to our presenters to see if we can get some additional answers, and I'll have them in the write-up on our blog. All right, Michael, thank you so much.
Thank you.
And at this point, we're going to go ahead and turn it over to Bob Foreman.
Good morning, everybody. Can you hear me okay?
Yes, Bob, we hear you great. Thank you.
Fantastic. All right, need to check that, Hard act to follow, Joey and Jill and Michael. Thank you so much for some great presentations. Again, my name is Bob Foreman, and I am going to talk about the Lost ECL tutorial. Now, I realize that, this Tech Talk is open to everybody, internally and outside of LexisNexis. And so even the question about have you visited David Bayless's personal website, a lot of people may not know who David Bayless is. And also the ECL tutorial, some of you may not know what Hpcc and ECL is. So just to get everybody on the level playing field, those of you out there who are looking at this Tech Talk for the first time, Hpcc is our platform for distributed data processing, and ECL is our common language that we use. So that's the language I'm going to show you today. I don't have a lot of slides. We're going to be going into my screen share, and I'm going to show you the integrated development environment, the ECL IDE, and we're going to talk about David Bayless's Lost tutorial. So you see my slide right here, the quick poll, have you ever visited David Bayless's personal website? So just a quick yes or no on that one. And this is very interesting how this all got started. David's personal website, when you first come to his main page, you're going to see a title for Bible exposition. And believe it or not, I went to a church service where David was speaking about one of the books of the Bible, and he referenced me to his personal website. And I went out to his personal website, saw the front page, but then I noticed a link that said computers. And I said, well, this is interesting. And so, sure enough, when I clicked on this link here that went to his technical documents page, lo and behold, I found the Lost ECL tutorial. And don't be afraid. I mean, no Rolling Stones are going to come and knock you over. And as a matter of fact, this is the man who developed ECL. And what a treat. What a treat the way he writes. If you've had the opportunity to hear him speak, he's our chief data scientist at Hpcc, for those of you that don't know him. But what a treat it is going through this tutorial and to discover this tutorial for the first time. So I'm going to take you to that website in just a minute. We're just going through some of these slides here. In David's tutorial, he divides it into actually 3 separate web pages. We're going to take a look at all 3 of them. Part 1 is getting the data from the outside world, getting it onto the Hpcc cluster, going ahead and cleaning the data, what he calls smacking the data into shape, organizing and structuring what he wants to do with the data, and then prepare the data for his intended goal, which was a Bible search utility using Roxy. So the heart of the search process that he writes is using a very powerful and interesting function in our ECL language called the graph function. So we're going to take a look at the graph function. We're going to talk about his search engine that he built. And then the last thing I'm going to show you is then taking that search engine, building a Roxy query, and then from there publishing it to our cluster and testing it. And that's the last thing we'll see. We'll actually test his query and go through step-by-step what was behind the scenes. All right, so from that point, I'm going to go into my screen share now. So hopefully this is going to work. This is my first time attempting this. So we're going to go ahead and go to the screen share. There we go. And let's go over to our ECL IDE. So everyone should see my ECL IDE right now. If not, Jessica, please give me a shout. But you should see my ECL IDE. And
we see it, Bob.
Fantastic, thank you. And from there, I also want to take you out to the web. And this is David Bayless's personal web page, and this is the link that I just referred you to earlier. That's called the technical documents page, and you see right at the top there, ta-da, the ECL language. So David, as he goes into his tutorial, he talks about his past experience with other programming languages, and he shares an anecdote about way back in 1988 when he had 6 megabytes of text on a PC with a 20 megabyte hard drive, and he was writing this the same type of code process. So he decided, well, you know, let's give ECL a test, let's give this a run for its money, and let's test the Bible search tool that he wrote in other languages, and let's now apply it to ECL. So the first thing he talks about is getting the public data source, and as you see here, there is a public data source on this page, ab1611.com. It's a version of the King James Version Bible. And David also mentions that he chose one that was kind of intentionally dirty so that he could play with ECL and clean the data a little bit more. So, all right. So we go out, we get this file, and where do we put it? How do we get started with it in Hpcc? Well, he talks about, first of all, getting the data into Hpcc. This section right here talks about our operation called spraying. So he copied this Bible to the Bible text into the landing zone, and the landing zone he did one of our 6 available spray techniques. For those of you not familiar with that, we have spraying of fixed length files. We have variable length files, which is called the delimited spray. We support spraying of XML. We support spraying of JSON. We support binary large object sprays. And there's also one called spray variable, which I believe is kind of a spray technique for IBM format files. And so David, looking at all of these different techniques, he finally chose to say, okay, I'm going to use the delimited spray. So the delimited spray got his Bible text into the cluster, distributed the data automatically, stored it on the disk drive of every node in the cluster, and then the first step after you spray is to actually then start to write your ECL code and define the file. So getting back over to my ECL IDE, one of the cool things I like about this tutorial, and by the way, I have a treat for all of you. All of you will be able to download all of this code that I'm showing you right now, and you'll be able to test it and look at it and go through everything in David's tutorial. All you'll need to do on your side is to spray. For those of you that are new to Hpcc, our website has links so that you can download the Hpcc VM, and your laptop can operate as a single node Thor or a single node Roxy, and you can test this code on your laptop without having to build a cluster. All right, so here is this module that David created. A module is nothing more than a special structure that helps you encapsulate code into one grouping so that all of the common elements that you're doing with the data can all be referenced together. And so David pulled in this, the file that I sprayed was called tutorial KJV and then my initials. And of course, like I said, the tutorial itself was just a variable length file that had no separators between the field data. And David is just saying, okay, I just want to get this data in so I can look at it. I don't know how long each line of the verses of the Bible is. I don't even know how long the file is. I'm just going to call it a variable length string. So I've got a little code here that I wrote that is just showing you this is the file coming in. This is the actual file coming in from the public website, and as we sprayed it to the cluster, treating each line of the file as a variable length string, you can see here that he's got one line that has the book of the Bible and then the verse, chapter and verse, and then the actual text of that chapter and verse. So the good news about this file is that it's already pre-sorted for us. It's sorted in book sequence. It's also sorted in chapter and verse sequence. It's good. All right, we like that. So what does David do? The first thing he does, he says, all right, you know what? He says, this file right here, I want to combine this logic together on a single line. I want Genesis 1, chapter 1, verse 1 on the same line as the actual verse. So the first thing that we do is introducing to you in ECL a special function called rollup. So this rollup function is designed to remove duplicate records. However, in this case, we're rolling up, and what records are we throwing out? We're going to throw out that record that's got the $sign in the chapter and verse, and we're going to merge it with the verse text on the second line. So that's, again, essentially what a rollup is doing here. So the rollup itself is taking that first line of text, the second line of text, combining it together. And David's got some graphics along the way here. After he's rolled up, this is what you're going to see. So after the roll-up process, he's got this text information with the chapter and verse. All right, moving forward, going back over to the ECL IDE, what's the next step? So after he's combined the text information with the chapter and verse, one of the most powerful and popular techniques in ECL is the ability to transform the data using a memory table. And a memory table is simply a file that gets stored in memory. So David, in his table record structure, is starting to shape the data. And he says, I want to put a book in a separate field. I want to put the book number in a separate field. I want to take the chapter and the verse text and put it into a separate field. So we are now standardizing the data into a fixed record set, and from there we're going to be able to build our inverted index. Now, also, I have to tell you, I took a little liberty of David's code. Some of the stuff that he wrote was kind of old school, and I am leaning more towards the open source product. So I am importing the string library that David was using, and in order for you all to see that this is code that's already been written, this is already code libraries that are already available to you in ECL. So I'm calling it slib for string library. So you see, David's got a couple of functions that he wrote that are going into the information, pulling out the chapter, pulling out the verse, and then he's applying it to this table that he's building. So he's doing a lot of substringing here. He's calling some string functions, and he's also then using another string function called getNthWord. So that's going to actually go through, count word by word through the verse, and give us a word count. So he goes through this table, he builds the table, and now at this point, going back over to his website, after the table is built, you can see now that we've gone from that free-form text into actually something that's becoming more structured. So you see the book, the name of the book, you see the chapter, you see the verse, and you see the verse text. So we're getting close. We're getting close to doing what we want to do with this Bible search utility. All right, so back out to my King James smacking the data into shape. You might notice also that the book number back in that page I just showed you was empty. So here is another ECL function called iterate, which we're using to calculate the book number of the Bible. So we all know that there's 66 books in the Bible. David is processing each record in pairs, and if the book number, the book name changes on the following record, he simply increments the book number. So this is something I talk about in class, the use of iterate, the use of processing pairs of records. And at that point of the game, so once again, you see the input of this had a book number that was all zeros, and then after the iteration, you come back in, and now he's got book numbers. So we're at a point of the game right now where the data is looking real good, but David wants to do a few more things before he starts his search utility. So here is the first index that he's building, and this index is called a payload index because the index is reading the text of his structured data that he's creating. He's now giving us a search into the index by book number and chapter and verse, and as a payload in the index, he is putting in the verse text. So when we publish this query to Roxy, and we do a seek on this index by book number and chapter and verse, the verse text is automatically stored internally inside the index. So there's no need for us to go back to the original base data set to get the rest of the information. Everything is included in the index. Now, of course, an index is a declaration of an index. In order to create the index, we need to build it. So this language statement right here builds it. And the rest of this King James Version is just some functions that David wrote to go into that index. So he's referencing key here, he's referencing key here, which is the name of his index. And here's where he's extracting the full text information with the book number information and so on, and allow him to search for the text information. And again, because of the time I've got, I mean, he talks about this get function, and he made it a little more complex than he needed it to be because he wanted to be able to search into the entire, by a whole chapter or by a whole book of the Bible. So he's got that in place with that get function. All right, so real quickly, now let's get into the meat of this. After we smack the data into shape, now it's time to build the inverted index. In this conversion model, he starts with a file that he just polished and cleaned up, and now he says my index is going to keep track of every word in the Bible, and also he's going to keep track of the book number, what chapter number, what verse number, and the word position where that word appears in the verse. It's simpler than it sounds because all David's doing here is one of our other specialized joins called normalize, where the first parameter is the input text of the file we just cleaned, and then he's calling the normalize using one of our string library word count functions. So for each verse of the Bible, he knows how many words is in each verse. Normalize calls this transform. It uppercases all the words, and there's a reason for that, so our search becomes very easy. And then everything else gets moved over into the record structure. And so at the end of this normalize, we have our first thing called record. And I'll show you what that looks like. I just can't believe that I'm running short on time with this already. There's just so much to talk about. Anyway, here's the inversion index right here, that output of that normalize. That's the book number, the chapter, the verse, and every single word in the Bible. So this is the output of the normalize, and now this is what he's going to use to build the inverted index. So back over to the code itself. Go back over to the inversion. Down here he's creating the index of the output of the normalize that we just saw. So normalize out to record, and then build the index on the record. And now, here is the heart of the search function for the Bible. And here is our graph function. So the graph function is a fantastic, I want to say an iterative tool, if you will, that what David first does is he is going to allow people to enter any amount of search words. So, again, gosh, I'm so short on time. I'd really like to talk more about this. This is a simple example of what David was trying to do. So he takes this key that he built. He is, first of all, limiting the key entries to the word love, and then he's taking that result and then joining it with the word God to find all the verses that have love and God. So that's what this join is doing. It's doing an inner join by default, and then when we take a look at the two-word search, this is all the verses that have both the word love and God in the Bible text. And notice it's a cool search because it's not showing you all the text, but it's showing you enough information that David can go back and get the Bible text if he wants to. So this works for 2 words, and David then says, well, what happens if I want to search for 3 words? What if I want to search for 5 words? How do I do that? And that's where the graph function becomes the hero. So what David does is he passes the graph function a set of data sets, which essentially is nothing more than the words of the search that he's doing. So if someone's searching for 4 words, it's going to pass a set of 4 elements. If it's a set of 5 words, a set of 5 elements. On the first pass of the graph, he simply does a project, which a project is simply looping through the record, looking for the matching word. Once he finds all of the matching words, then in the second pass and the third pass and so on, graph takes the result of the previous pass and then applies it to the next element of the set. So again, if I'm searching for love of God, it's going to make a first pass and find all the verses named love. Then it's going to make another pass and find love of, and then it's going to make another pass and find love of God. So the graph function returns the result. And by the way, we're also deduping it because there could be some verses that have the word love more than one. So we don't want to have duplicate book numbers and chapters and verse. We want unique results. So we're deduping this graph result by book number and chapter and verse. The project here at the end is simply going back out, taking our search result, and giving us the full result of our search. So back in my inversion text, you see here that the first inverted index followed by the search result, which is this guy, book number and chapter and verse. This is the result of the search, which is our graph function. And finally, taking this, joining it with our another index, we finally then, ta-da, pull all the verses out that have the matching search terms that we're looking for. So it's pretty awesome. I love this tutorial. I can talk about it all day. I'm just going to finish up right here. After you've created the search thing, then it's the ability to put it into a Roxy query. So this same search process that I showed you using the graph function is now dropped into another file called a search service. We're uppercasing what the user enters to match against our uppercase words in our inverted index. David is also doing something where he takes the book number of the Bible and then returns a more descriptive string of that book number. All right? And then once he gets his result, he runs this get batch, which again links everything, and then he's doing some final cleaning up to do some concatenation, the name of the book, the name of the chapter, and the name of the verse. Watch how quick it is to get this ready for Roxy. I'm going to change my target to Roxy. I'm going to compile this query right here. Down at the bottom, you'll see submitted to my, by the way, this is my 3-node Thor training cluster that I'm using today. Only a 3-node Thor. So the search service has been compiled. I then go into the ECL watch. I go into my publish option. And I'm going to say this is our Tech Talk search service. All right, so Tech Talk Search Service, I'm going to just submit this. A green bar comes across telling me that the query that was compiled and tested on Thor is now published and copied automatically to my Roxy cluster. And finally, we go into my cluster, and I'm going to just refresh this because I should have a new Tech Talk Bible Search Service out here, and there it is, Tech Talk Search Service. And now if we search for the word love of God, here's all the Bible verses for love of God. If I go back and say, well, what about love of dogs? You know, I'm a dog lover. I've got 2 rescue dogs in my home here, and love of dog, no result. Oh, all right. Well, is dog in the Bible? I don't know. Let's find out. Yeah, dogs in the Bible, unfortunately 15 verses, and they're not very complimentary to the dog. And but then again, if you search for cat, you're not going to find anything there. No cats in the Bible. There is wine in the Bible, of course. And I did again, this is a case-insensitive search. Look how fast it is, too, going through the verses of the Bible. And then finally, well, there's no wine. There is wine, but there's no beer in the Bible, unfortunately. There is, by the way. There's 2 cities in the Bible called Beer. And when from thence they went to Beer. So did you know there's a town in the Bible called Beer? I didn't know that until today. All right. So I am going to go back over to our presentation mode, and then I'm going to go back to our slides. And I'm sorry I ran a little bit late. I get excited about this. And so we're back over to our slides. And here's the good news, everybody. Well, here's a little poll question. Have you ever used the graph function in your own ETL projects, those of you using ECL? And then finally, our last slide here is the link to download those examples that I just showed you. You can download them. You can spray the data, go out to the public website to get that data, spray it, test it, have fun with it. All right, so that's all I have for you, and thank you for sticking around and attending. It's been my pleasure to help you all and be here for this Tech Talk. Again, my email is also here, robert.foreman@lexisnexusrisk.com, if you have any questions. Jessica, turn it back to you.
All right, thank you. So it looks like from your first poll about whether people have visited David Bayless's website, it looks like 70% had not ever visited, where 30% had. So hopefully that 70% now has the new data resource, so that's good news.
Fantastic.
And it looks like we have a few questions. So the first one is, I see that the index is using numeric fields in this case, and the text is in the payload. Could we use alphanumeric fields instead? And are indexes using numeric fields, are those more efficient?
You know what? I would say more efficient, maybe a little bit, but no, you can use anything as a index search element, alphanumeric strings. It will sort by that string version, of course. Thankfully, ASCII is A through Z. Everything sorts uppercase first and then lowercase. And so, yeah, certainly indexes using string fields and alphanumeric fields are absolutely supported.
All right, fantastic. One last question. So what was the popular ECL technique that was used when you were smacking the data into shape?
Oh, what was the well, there was a bunch of techniques we were looking at there. We were looking at projects, and we were looking at roll-ups. We were looking at tables, memory tables. And so we were using a memory table. Inside the record structure, you can put default values in the memory table. And that was essentially the trick that I was showing you, where it was smacking the data into shape by reading through the original raw text and extracting the chapter, extracting the verse, extracting all of the pertinent information, and then putting it into a memory table from which then we were able to continue working with and add the book number and then eventually build an index on our final result.
All right, Bob, thank you so much.
There's one more question here, real quick, Jessica, if I may. What if a memory table doesn't fit the memory of a single Thor? Does it still work? Yes. We have something. You have RAM on your machine, and you have RAM for each node of your cluster. If you're using a single node and you run out of RAM, then what would happen is a disk spill. So it will use disk as additional RAM, and it will get the job done. The only caveat, drawback to that is that your performance may drop a little bit because the I/O is now going into disk for some temporary RAM. So that's the answer to that. No, if your memory runs out of RAM, then it will go to disk and do something called a disk spill. All right.
Great. Thank you, Bob. And just really quick, from your last poll, have you ever used a graph function in your own ECL project? 78% no and 21% say yes. So that's the result there.
All right.
So just to wrap things up, if you would like to submit a talk for an upcoming episode, we would absolutely love to have you join us. If you have a success story to share, if you want to pitch a new use case that you're using, perhaps even from an external company or within LexisNexis, either one of those is fine. If you have a new application that you want to demo or some helpful ECL tips, sample code, even if you have a suggestion for the roadmap, we would love to hear from you. So please send us an email at techtalks@hpccsystems.com, and please save the date for our next Tech Talk, which is coming up on April 20th. So for the questions we weren't able to answer today, please refer to our blog. We'll have a full write-up, and we'll have some of those questions there as well. Thank you all for joining us today.